This video is going to look at problem number 4 from the Purdue High School Programming Competition 2014. It's the Roman numerals problem. And it's a classic problem. It's asking you essentially to change a regular number or an Arabic number to a Roman numeral or vice versa. And they have all these conversion factors. There's the cases we have to worry about in terms of letters being before other letters or after letters in Roman numerals. So if you've never actually done Roman numerals before, you should play around with them first before you attack this problem. So to code this, we're going to have to read in first how many test cases we need to answer, and then we'll start reading in the different things that are read in. So scanner, this is starting to get repetitive in all my videos. I'm doing the exact same thing to start every time. Let's import scanner. Then I'm going to read in my first test case. Or my number of test cases, and I'm going to read in the whole line again, and then convert it to an integer because I'm going to be reading in letters as well, so I don't want to mess around with scanner screwing up next int sometimes. I'm going to have a loop that's going to run a number of times. That matches the number of tests. And then for each test, I need to read in the line, and then I have to make a decision. Because based on what has been entered in, I either have to convert an Arabic number to Roman numerals or a Roman numeral to Arabic. So essentially we need to know if this number has letters in it or if it has digits in it that we're used to, like 0 through 9. And I'm going to introduce something that we haven't really used in AP Computer Science because it's not part of the subset, but is very handy in a lot of computer applications, and that thing is what's called a char or a char. People have different names for it, ways to pronounce it, like GIF versus GIF. I say char, so I'm going to make a char first and assign it to have the value of next first character, or the one at position 0. And what that gets is just the one individual letter at the beginning. Unlike strings that can have lots of letters in them, a char can only have one character, one digit. And the nice thing about chars is in the background they're really just numbers. So you can write commands like this. If first is bigger than or equal to a in apostrophes means it's a char, not a string, and if the first one is also less than or equal to z, what that means is that our letter, or our character at the beginning of next, must be alphabetical, at least uppercase alphabetical. Otherwise, it's going to be something else, and assuming that our input is reasonable, it'll be a digit 0 to 9. So now we can break our code into two different cases. In one case, we're going to be converting the Roman numeral. The other one we'll be doing the other direction. So I'm going to assume for a moment that I have a magic method here called convert Roman to normal, which I will then print out that result. And then likewise, I'm going to assume I have the other method, which will convert a normal number to Roman, and also print out the result. So these are the two methods I need to finish. So one nice thing that Eclipse allows you to do is you can actually have it autocomplete methods. So I need this method, and I need this method. Bam, bam. They are now made, and now I have to make them work how they're supposed to. I don't know if one's particularly easier than the other. I suppose that convert normal to Roman is a little bit easier. I don't know if it really matters, but I will, yeah, I guess I'll do this one first. So I'm going to need to build a result, and wait, that's not right. Oh, I know why. So I kept looking at this being confused. What I wanted to do up here is, well, I'll leave it like this. So here I've taken in a normal number. So this is a number like 1, 2, 3, for example. But right now it's a string, so I'm going to take next and convert it to an integer. Value equals integer.parseInt next. All right, so value now is a regular old integer number like you're used to, and we're going to try to convert it now to Roman numerals. So the process that I used, which is not necessarily elegant, but I think it's pretty reasonable, is that I first want to go through and find all the thousands. Because for every 1,000 there's in this number, I need to add an m. So to speed this process up a little bit, here's a loop I would add to do that. And let me make this n instead. So while my value is greater than or equal to 1,000, then I need to add another m to my result, and then decrease my value then by 1,000. So like if the number was 2,000, it would add 2 m's and decrease n by 2,000, and that would be out of numbers. My answer at the end, I'd have to return a result, and assuming that the only thing the number has is 1,000s, then I'd be great. But then I have to worry about other cases. So after m is supposed to be the d's, which are the 500s, but there's a special case we have to worry about because when you have 900, you don't represent that with like, what would that be, a d and 4 c's, because 4 c's in Roman numerals is not allowed. You can't have more than 3 of a certain digit in a row besides m's. So I'm going to deal with the 900 case next. And this just can be an if case. If the number is bigger than or equal to 900, that means that I have to add cm, which is 100 less than 1,000, to the number, and then decrease the number by 900. I don't have to do a loop there because there can only be one cm. There can only be one 900. Likewise, I can do the same thing for 500s. I'm just going to add one d to it. You couldn't have two d's because that would just be an m. So don't have to worry about that. Next would be, you think, the c's, but actually I need to worry about 400 next. So if the number is bigger than or equal to 400, then I need to add a cd, because that represents 400, 100 less than 500. And doing really well. Keep going. The next thing I need to do is the hundreds. So I need to add a bunch of them potentially. So if the number was 323, I'd have to add 3 c's, and that's what that loop will do. Now I have to do the 90s, and that's because I'm not allowed to have what would be a L followed by 4 X's. I would have to have an X followed by a C, which is 10 less than 100 or 90. Then I also have to do any 50s that I can do. I can have at most 150, because if you have more than 150, then you would have 100, and that would just be a C. I have to do a special case for 40, because if you have try to do 4 x's, that would be 4 in a row, which you can't do. So I have a special case for XL, 10 less than 50, and we're almost done, sort of. Now I need a case for 10s, so I add my 10s. Then I need a special case for 9s, special case for 5s, a special case for 4s, and then last but not least, finally, I'll add in any leftover 1s. It's a lot of work to get this done. I don't know if there's a better way to do this, but this is the way that makes sense to me. So this is my finished algorithm for converting a normal number like 1, 2, 3 to Roman numerals. So the next one we have to look at is converting a Roman numeral number to normal. And to do this, I'm going to actually go ahead and write another helper method, which is going to get the value of a Roman numeral. And I'm just going to do it by an individual letter. And there's just a bunch of cases. Not to bore you, I'll just add them in right here. So essentially, if the letter is an I, the value is 1. If the letter is a V, the value is 5, X, 10, blah, blah, blah. So a bunch of cases, the last one being default to M, so it's 1,000. And I'm going to use this up here in my method. And this one's going to be a little bit more elegant. I'll be able to use a loop for it. So I'm going to end up with an integer answer. And I need to loop through every letter that's in, I'll call it Roman, sorry. Every letter that's in my Roman numeral. I'm going to get each letter one at a time, and I'm going to get its value as well. So I'm now using the method that I just wrote to find out what it's worth. Now, I would like to just add that value to the answer, but there's a special case I have to worry about, and that's if the letter after the letter I'm on right now is a bigger valued letter, because in that case, then I have to do subtraction. So I need to write an if case that checks to see if I have a letter after me, and if so, then I need to get the letter after me. So at I plus 1, get its value using the function I just wrote, and then I have to see if the next value is greater than my current value. If so, then my answer will increase by next value minus value. So that's the subtraction. I'm adding kind of the combination of the next two, subtracting. So if an easy way to think of this is if the first letter was I and the next letter was X, it'll be adding X minus I, or 9. So IX is 9. This is doing that correctly. Now what's interesting here is I've taken care of two letters at once, and if I'm not careful, my loop will actually process another letter again. So to make it skip the next letter, I'm going to do an I++ here, so that I skip two letters on this iteration instead of just one. So now I have some other cases I need to fill in here. One is if it's not true that next value is bigger than value, then my answer should just increase by the value. Just like if I see an X, increase by 10. Likewise, if there isn't another letter after me, then my answer should just increase by value as well. And if I return answer, my code should be done. So I'll go up here and I can test this out to see if it's working. And I'll try some of their test cases. So let's go ahead. One of their test cases is the number 3, and my code says 3 i's. That's good. They want xii. xii gives me 12. That's correct. xcix. xcix. 99. Wait, xcix. Is that 9? Oh, yeah, that's 99. Good. Oh, always good to double check your thinking there. 756. 500 to 100 to 700 plus a 50. So yeah, that's working. Wow. And we can keep doing these kind of in forever. I'll do the last one here. 3984. Yeah, it looks the same. So I'm pretty confident I have a working Roman numeral converting program. It uses a lot of new concepts in here, like the char function. If you have a better way to do this, you can let me know. I'd be curious to see that. But this should be the answer to the Roman numeral program.